Operating system is a software that manages computer hardware resources and provides services for computer programs. It acts as an intermediary between the hardware and software, allowing them to communicate and function together. The operating system manages tasks such as memory allocations, handling input and output, managing file and folder, and controlling peripheral devices. Some examples of operating system include Windows, Mac OS, and Linux. Uh, Operating system course. If you are a beginner, good starting point would be a course that covers the basic of operating system, such as what they are, what they do, how they work. These courses will typically cover topics such as history of operating system, different type of operating system, Windows, Mac, Linux, the core component of an operating system, the kernel, the shell, the file system, how operating system manage hardware and software resources. Once you have basic understanding of operating system, you can then move to more advanced courses. These courses will typically cover topics such as process management, memory management, file system management, security network. Operating system. An operating system OS is a software that acts as an interface between the user and the computer hardware. It manages all of the computer resources and to provide common services for application program. Some important functions of an operating system: process management, memory management, file management, device management. In process management, the OS keeps track of all the programs that are running on the computer and allocate resources to them as needed. Memory management, the OS management of the computer memory and keeps track of which program are using which parts of the memory. The OS manages the computer memory and keeps track of which programs are using which parts of the memory. File management, the OS keeps track of all the files on the computer hard device and allow user to access and manipulate them. Device management, the OS control all the computer devices such as keyboard, mouse, printer, and monitor. Security, the OS protect the computer from unauthorized access and malicious software. Different types of operating system, and the most popular: Microsoft Windows, Apple Mac OS, and Linux, Android, iOS. Microsoft Windows is the most popular operating system in the world. It's used on a wide variety of computers, from laptop to servers. Apple Mac OS. Mac OS is the operating system that comes pre-installed on Apple computer. It's known for its user-friendly interface and stability. Linux is a free and open source operating system. It's very popular among developer and the power user. Android is the operating system that is used on most smartphones and tablets. iOS is the operating system that used on Apple iPhone and iPads. Operating system, the course content. The course consists of some sections. Section number 1, introduction to the operating system. We will begin with a high level introduction to operating system. The operating system act as a platform for information exchange between your computer hardware and the application running on it. Most people are familiar with Windows operating system family like Windows 10, XP, and Vista, and later Windows 11. Apple suite of operating system like Catalina, Majova, or Sierra. But for the purpose of this course, we will focus on Unix, the open source OS deployed all over the world in both personal and commercial system. First, we will start with discussion on some of the earliest operating system, including those which are considered precursor to the operating system that we are familiar with today. Then we will review the general OS structure and give a basic function overview. The functional overview will include a discussion of the modern operating system and devices that we are familiar with. In section 2, process and the threads, we will discuss two central building blocks of modern operating system: process and threads. Process, instance of a running computer program, and the threads, a specific task running within a program, are integral to the understanding of how an OS executes a program and the communication of information between each of the computer architecture layer. We will start with an overview of each concept, including definition, uses, and type. We will then discuss the commonalities and differences between process and the threads. We will conclude this section with a discussion on context switches and the important role they play in CPU scheduling, which will be discussed more in the section number 4. Synchronization, the section number 3, synchronization, because a number of different entities will need to access data. It's important to learn how to maintain a consistent view of data across the OS. This is why we need a good synchronization management system. We will begin this section with an overview of why synchronization is so important to an operating system and the problems that could arise if synchronization is not handled properly. Also, we'll discuss and continue with overview of race condition system flows in which problematically dependent on the sequence of other events, and finally semaphores as a way of preventing race conditions and other more advanced alternatives to semaphores such as monitor and messages. The CPU scheduling, central process unit. The CPU scheduling deals with having more process threads than processors to handle those tasks, meaning how an operating system works. A good algorithm will optimally allocate resources, allowing an efficient execution of running program. A poor algorithm, however, could result in any number of issues, from process being starved out to allowing an efficient execution of running program. A poor algorithm, however, could result in any number of issues, from process being starved out to inefficient executing, resulting in poor computer performance. In this section, we'll first discuss the CPU problem statements and the goal of good scheduling algorithm. Then we will move on to learning about types of CPU scheduling, such as imperative and non-preemptive. Finally, we will conclude the section with discussed operating system. Deadlock is a paralyzing process that results from improper CPU scheduling, process management, and synchronization management. During this time, processes are blocked as they and synchronization management. During this time, processes are blocked as they compete for system resources and only communicate with each other. It can't be guaranteed that the deadlock may be avoided 70% of the time. It's important to know how to avoid the deadlock state and how to recover from it once it has been achieved. We will build upon the previous 2 units, CPU scheduling the process and thread. When discussing deadlock, we will discuss what deadlock is by establishing a working definition and the condition in which it presents itself. Memory management. Memory is the oil that keeps the computer running smoothly. It's present in various forms through the entire computer system. As software developer, it's absolutely essential to have a solid understanding of the role memory play, so that you are able to efficiently use memory in your program, as well as understanding what is going on under the hood. Should a problem arise, we will discuss the role of memory in the operating system, first with an overview of the memory hierarchy and how memory and OS interact with each other. We will move on the discussion how memory is allocated for different purposes. Finally, we discuss the two main topics regarding memory access. We will discuss a general overview of the file system, a look at file allocation and the methods, as well as the disk allocation algorithm. Security. Security is an important part of the operating system. There are many threats today to computer system. These units will begin with a brief, as well as the disk allocation algorithm. Security. Security is an important part of the operating system. There are many threats today to computer system. These units will begin with a brief overview of security issue, look at type of malware, and discuss several security techniques such as access control, intrusion detection, and malware defense. Networking. Computer networking has become an increasingly important field. When we discuss networking, we are not just referring to connecting computer together in about broader connection through the internet. This is the sections in brief, and we will discuss in every section these issues and these points in full detail. Thank you for joining me in this course.